So lesson 4.2.2, so part 2 of lesson 4.2 is special right triangles, calculating trigonometric functions. We are looking at filling in this chart here. You'll notice it says the most important chart you'll ever learn and memorize. This chart right here is a huge part of what we're doing the rest of the semester. Okay, this chart goes directly along with our unit circle that we're going to start working on soon enough. Okay, and we're going to go through today how to fill it out, where all the numbers come from. But you're not going to want to try and think through it every time of, okay, how do I get this? Where do I get this from? You're going to want to memorize this chart. And I will be up front and tell you that a quiz during this chapter will be completing this chart. I mean, it's generally like a 5-10 minute quiz because you've prepared and you know it and you fill it in. So it's not, but I usually do a quiz filling in the chart. Now, going along with filling in the chart, we'll also be talking about these triangles. So let's start. Officially, this should be some review from, I feel like you guys did these special triangles in geometry. Maybe in algebras, but definitely should have been in geometry. Whether you remember them or not is a whole other story, right? That's always the other story. So let's start with this first triangle. Special right triangle. This first triangle is what I'm going to call a 45, 45, 90 triangle, or 45, 45 right triangle, however you refer to it. Do you remember anything about the sides in a 45, 45, 90 triangle? You remember it's easier than the other one, is that what you said? Okay. I guess I could go with that. I was looking for a little more specifics, and it was easier, though. What can you tell me about the two legs? How do we know the two legs are equal? The legs are opposite the same degree angles, yes? Since my two non-right angles are 45, that means the legs are equal. When we refer to this, I use 1 and 1 to notate the length of the legs. And the idea is that, yes, the legs are equal. Do you remember how we find the hypotenuse? Should I go with no, we don't remember this? Well, officially, if you did Pythagorean theorem here, what would the hypotenuse equal? Square root of what? Do this Pythagorean theorem real quick. A squared plus b squared equals c squared. A squared plus b squared. 1 squared plus 1 squared is 2. So what's the hypotenuse? Square root of 2. Okay, when we talk about a 45, 45, 90 triangle, the legs are equal, and the hypotenuse is equal to square root of 2 times a leg. So if the leg has a ratio of 1 here, it's square root of 2 times 1. If your leg is something else, the hypotenuse is always square root of 2 times that length of that leg. So I'm going to write two things here. One, I'm going to write that the legs are equal. And that is always true. And then the other piece of information I'm going to write is that the hypotenuse is equal to the square root of 2 times the length of the leg. And this is true of any 45, 45, 90 right triangle. If you know the length of one side in a 45, 45, 90 right triangle, you can find the other sides. Got it? So 1, 1, square root of 2. Okay, our other special right triangle is a I'm going to say 30, 60, 90, but same thing. Okay, 30, 60, 90. In a 30, 60, 90. Do you remember anything? depends which way you're going. I always tend to start with the short leg, and I think of the short leg as 1. So that's kind of your base length, so to speak. The short leg is 1. The hypotenuse is the easy one. The hypotenuse is just 2 times the short leg. And the, what I would call long leg, so the leg opposite the 60, square root of 3. Square root of 3. So in a 30, 60, 90, your short leg is kind of your beginning amount. Your hypotenuse is 2 times the short leg. And your long leg, so the leg opposite the square root of the 60-degree angle, is square root of 3 times the short leg. Again, I'm going to write this information down. So hypotenuse is 2 times the short leg. And the, what I call long leg, is square root of 3 times the short leg. Now, if you're working backwards to find something, you might have to divide by 2 or divide by square root of 3. But if you're given the short leg, it's always a multiplication relationship. Do those sound the teeniest bit familiar? I promise you learned them at some point. At least you should have. Okay. Okay, well, what I'm going to tell you guys is part of your quiz, and again, I don't even know when the quiz is going to be, but we will do a quiz over this chart, and part of the quiz includes the triangles. When I say the triangles, I'm talking about just being able to fill in on this one, the 1 square root of 3 and 2, and on the other one, the 1 square root of 2. Just knowing the relationship between those sides, because that is incredibly important in our next step, which is filling out this chart. Okay? So, you ready for the chart? On this chart focuses on 3 basic degree angles. 3 basic angles that are what I would call our reference angles. They are 3 major angles in our unit circle, and they're all 3 in the first quadrant, but then they also, we use them all around the unit circle. So these are ones that you'll become very familiar with. 30 degrees, 45 degrees, and 60 degrees. Now, the first column is asking for radians. Okay, dig in those brains. How do you change from degrees to radians? You multiply by pi over 180. So what is 30 degrees times pi over 180? Times pi over 180, so think 30 pi over 180. What do you know about 30 over 180? 1 over 6, because it's 3/18, which reduced to 1/6, so this is going to be pi over 6. Let's go ahead and do that whole radian column. 45 degrees. How do you change 45 degrees to radians? Multiplying by pi over 180. Do the math. What was it? Pi over 4. And how do we change 60? Multiply by pi over 180, and what is 60 times pi over 180? Pi over 3. Okay, guys, you're going to need to, my opinion would be, memorize those. You're not going to want to have to, those are ones that we use so much, you're not going to want to have to convert every time. Okay, I need to convert 30 degrees to radians. You're just going to need to know that they are equivalent. There are some tricks that you'll catch. 45 degrees is pi over 4. Notice the 4's in common. And then I try and notice that my 6's and 3's are in opposite places. And that 30 degrees is pi over 6. And 60 degrees is pi over 3. So my 3's and 6's are opposite, if that makes sense. If you don't like my random thoughts of how I remember this, come up with your own. Okay? Okay, guys. So, in that first box we're going to fill in now is we're going to be filling in the sine of 30 degrees. How can I find the sine of 30 degrees? What is sine? Opposite over hypotenuse, yes. SOHCAHTOA from yesterday. So sine is opposite over hypotenuse. We have a 30, 60, 90, yes. So sine of 30, we're using our triangle. Opposite over hypotenuse, 1 over 2, or in other words, 1/2. This is why you have to know the triangles. Because if you forget something on the chart, how do you figure it out? You go back to the triangles. Okay? I'm going to go ahead and go all the way across and with the 30 degrees. So let's look at cosine of 30 next. So here's 30. How do I do cosine of 30? Adjacent over hypotenuse. And what's adjacent over hypotenuse? Square root of 3 over 2. Whoops. Don't do what I just did. We're going across. Okay. So, you guys okay with that one? And then tangent. What do you know about tangent? SOHCAHTOA. Opposite over adjacent. What's opposite over adjacent? 1 over the square root of 3. Now, notice I did write 1 over square root of 3 in here. Or, what's another way to express 1 over square root of 3? Square root of 3 over what? 3. The idea being, technically, how do we rationalize this? To rationalize this, we multiply by square root of 3. If we multiply the denominator by square root of 3, it becomes 3. If you multiply the numerator by square root of 3, it becomes square root of 3. So square root of 3 over 3. Something like a quiz filling in the chart, I'll accept either of those answers. 1 over square root of 3 or square root of 3 over 3. There are times, though, depending on what we're doing, where one answer is easier to use than the other. And so, it's kind of good to know both. Okay, or if you can remember 1 over square root of 3, you can always rationalize that. But it's kind of good to know both, and that's why I have both in the chart. Okay, did you follow where all those came from? Okay, you ready to do the 45-degree row then? With my 45-degree row, where do I go? 45, 45, 90? You can use either 45-degree angle. Okay, so sine of 45. What about sine of 45? Opposite over hypotenuse. 1 over square root of 2. Now, again, notice I wrote 1 over square root of 2. So I am good with 1 over square root of 2. However, it's good to know the other two. Or, what is 1 over square root of 2 when you rationalize it? Square root of 2 over 2. Okay? What about cosine of 45? Adjacent over hypotenuse? which is also 1 over square root of 2. Or, instead of 1 over square root of 2, you can say square root of 2 over 2. And last 45 degrees, tangent. What about tangent? Opposite over adjacent, 1 over 1, which is 1. Okay. 60-degree row. Sine of 60. So that means you're looking at the 60-degree angle here. What's sine of 60? Opposite over hypotenuse, square root of 3 over 2. Cosine of 60, 1 over 2, adjacent over hypotenuse. And tangent of 60, opposite over adjacent, square root of 3 over 1, which I'm just going to use square root of 3. Okay, whether you filled your chart out with me or whether you jumped ahead and filled it out on your own, doesn't match mine. It's important to have this correct moving forward. Okay, and again, this is something, yes, technically could you always go in and use your triangles and fill that out? Yes, you can. However, it's good to just know it, and that's what I want you to do. Know it. Okay? Now, next part of the example chart stuff. Example 1 says find the cotangent, secant, and cosecant of each of the 3 angles from above. What do we know about cotangent, secant, and cosecant? They're the reciprocals of the ones we just did, right? So, your chart on the quiz is actually going to be double the length, because I'm going to have sine, cosine, tangent, but then I'm also going to have the reciprocals. So, I'm going to set up an equivalent chart down here. I'm still going to have degrees as my first column, and I'm going to have radians as my second column. And then, up above, sine was first. What is the reciprocal of sine? Cosecant. So I'm going to have cosecant as my next piece in my chart. Then it was cosine. What's the reciprocal of cosine? Secant. And then lastly was tangent. What's the reciprocal of tangent? Cotangent. So those are the columns I'm going to have on my chart. Now the angles we were asked to do, same angles as last time. 30 degrees, 45 degrees, and 60 degrees. Okay, once you get your chart set up, start with radians. What are your thoughts on radians? It's the same? Yeah, did they change from above? No. 30 degrees always equals what in radians? Pi over 6. 45 degrees always equals pi over 4, and 60 degrees always equals pi over 3. Okay. What would be the easiest way to fill in cosecant? Take your sine column from up above and reciprocal of each. Now, if you'd prefer to go back to your triangles, you can. But to me, it's just easier to use our reciprocals. So, cosecant. Cosecant of 30. Well, What was sine of 30? Sine of 30 was 1 over 2, so what's cosecant of 30? 2 over 1, or in other words, 2. Let's go ahead and go all the way down the cosecant column. So, cosecant of 45. It's going to be the reciprocal of sine of 45. What do you want to tell me? The easier one to look at is the 1 over square root of 2, because the reciprocal of 1 over square root of 2 is square root of 2 over 1, which is just square root of 2. And then lastly, cosecant of 60 degrees. Well, it was square root of 3 over 2. What's that reciprocal? Two over square root of 3? Except, what's another form of that? Yep, if we rationalize and multiply by square root of 3, it's 2 square root of 3 over 3. Again, I will accept either. But it's just to remember to rationalize, you multiply by square root of 3, top and bottom. Okay. Secant. How do I fill in my secant column? Reciprocal of cosine? Okay, so if we're doing secant of 30, what was the cosine of 30? It was square root of 3 over 2, so now I'm going to say 2 over square root of 3? Or, what's the other alternative? Two square root of 3 over 3. Didn't we just do that? Are you noticing some relationships on this chart? I'll go back and talk about some of them here in a moment, but there are definitely some ways to help you memorize this. Okay, what about secant of 45? It's the reciprocal of 1 over square root of 2, so it's square root of 2. And what about the secant of 60? Reciprocal of 1/2, so it is 2. Okay. And lastly, the cotangent column. How do I fill in the cotangent column? We're going to do the reciprocals of tangent. So, cotangent of 30. The reciprocal of 1 over square root of 3 is square root of 3 over 1. Cotangent of 45. What's the reciprocal of 1? 1. And cotangent of 60. It was the square root of 3, so the reciprocal of square root of 3 is 1 over square root of 3. Or, what is that when rationalized? Square root of 3 over 3. Okay. If you jumped ahead of me, take a moment, make sure your chart is right. I'm not saying it's a bad thing if you jumped ahead of me and finished ahead of me. But just make sure you filled it in correctly, yes? Now, one thing I forgot to mention up above. Did you guys catch some of the connections? I mean, obviously, it's a good connection to notice that sine and cosine of 45 are always going to be the same, right? So if you know one, you know the other. Did you catch the other sine and cosine connections? 30 and 60 are opposite, right? So 1/2 here, 1/2 down here. Square root of 3 over 2 in the alternating boxes. Okay. Tangent of 45 is 1. These other tangents are reciprocals of each other. So that helps as well. Okay. So lots of different ways to remember this chart. Now, before I go into the bottom section, homework tonight. There are 3 pieces of homework, or 3 sections in homework. The first section says no calculators. The second section says calculators. And the last section says no calculators. You have to abide by that. Because if you use a calculator where it says no calculators, I'm going to count it wrong. because you're going to give me crazy answers when I don't want crazy answers. Okay, so let me make sure I remember which section's which. I was going to kind of give you an example. So in 19 through 24, here's an example of what you might see in homework. And this is a non-calculator section. They might ask you for the cosine of pi over 6. You might see a problem like that in the first section of homework. And the directions will read, evaluate without using a calculator. Thoughts on how I can do cosine of pi over 6 without a calculator? Here's cosine. Do we have pi over 6 as an angle? Pi over 6. Right, and when we say pi over 6, that's the same thing as saying 30 degrees. They just gave it to us in radians. So what's cosine of pi over 6? Square root of 3 over 2. That's all. Homework is that easy. Okay? Now, if you use the calculator, you're going to get a crazy decimal answer, aren't you? And I'm not going to count it then. Okay, so that's what the first section of homework is like. Don't make it any harder than that. Use your chart, grab the numbers, you've got it. Should not take you that long, right? Now, the second piece of homework, the 29 through 40 says use a calculator. We'll talk about that in a moment. That goes down with example 2. But I do want to talk about 41 through 48. They would give you a problem such as, let me think about how I want to do this. Sine of theta equals square root of 2 over 2. Okay? So they might give you a problem like that in the second section of, or the last section of homework. And the directions would read, find the acute angle theta that satisfies the given equation. Give theta in both degrees and radians. You should do these problems without a calculator. Well, what do we do here? They want to know what theta is. How do I find the angle? On the chart. Here's sine. Here's square root of 2 over 2. Where does that happen at? At 45 degrees or pi over 4 radians. Sine, square root of 2 over 2, happens at 45 degrees, which is also pi over 4 radians. So you have two answers there. 45 degrees and pi over 4. Sorry, I'm off the screen. Again, use the chart, no calculator, right? So 2/3 of your homework is no calculator. You use the chart. Because that's a lot of what today is, learning how to use the chart. Questions on that? Okay. Now, grab your calculators. Let's talk about how to use the calculators. Example 2. Evaluate each of the following on a calculator. And notice the first one is sine of 15 degrees. Can I use my chart for sine of 15 degrees? Nope. Doesn't have that connection. Yeah, you can't use the chart. When it is an amount that's not 30, 45, or 60, we can't use the chart. So, do you know how to use your calculators? Sine of 15 degrees. So, whether you're looking at a scientific calculator or graphing calculator, punch it in. What do we have? Sine 15 degrees. Answer should be 0.2588190451. No? You're not getting that?
There's a different mode because there's something.
Okay, so I know what I'm doing, so I planned ahead here. Notice the other part of the directions that I didn't read out loud says be sure to make sure you're in the correct mode. Okay, so your calculator can change mode. Notice 15 is what? It is degrees. So I need to be in degree mode. On this particular calculator, I can see right up at the top that I am in degree mode. If I wasn't in degree mode, it would say radian right here. Now, whether you can see that up top or not, we're all going to go to the same place to change it, and that is the mode button, right there next to the second button. So second row of the top, towards the top of the calc there, do you see mode? It brings up a graph or a page that looks like this. On mine, it's the fourth thing down is radian and degree. I'm in degree because my degree is highlighted. If you're in radian, your radian's highlighted. Can you switch it over, just arrow over to degree and hit enter? Then go back and try sine of 15 degrees again and see if you get my answer. Your answer, if you know how to use your calculator correctly, this is why I needed everyone to have their calculators with them today. Because this is the trickiest part of today's homework. Switching your calculator back and forth between modes. Okay? So in this particular problem, because there was a degree bubble, we needed to be in degree mode. Okay? And if I give this answer with 3 decimal places, 0.259 is what I'm going to say. If you're using a scientific calculator, there's ways you can use a scientific calculator to do this too. Okay? And all calculators that can do this are going to change modes. Did everyone get it figured out now? Okay, so we're ready to try the next problem? Next problem, B, says cosine of 5 pi over 7. When we do cosine of 5 pi over 7, please use the pi button. Don't try and type in 3.14 because that will cause you problems. Does your answer match my answer? What do you know about 5 pi over 7? It's radians, yes? So did you change your mode? I'm going to give you lots of practice on changing that mode. Okay, so because there's no degree bubble, you need to go back to radian mode. So use your mode button and go back to radian mode. And that's 5 pi over 7. So I just used the division bar. Negative 0.62348988019. Did you figure it out? If not, let me offer calculator help if you're not getting these answers. Because this is just the start of a chapter of going back and forth in your modes. If I do 3 decimal places, I'm going to say it's approximately negative 0.623. Are we getting them? Okay. What about C? Yeah, right now it's 57 degrees, 13 minutes, 15 seconds. Remember that DMS you learned about? You learned about it via video. I wasn't here that day, but you learned about it. Hopefully you remember it. And that 57 degrees, 13 minutes, 15 seconds, we don't have a way to enter that amount in the calculator. So we need to change this, first of all, into degrees, which also means what mode am I going to have to be in? We're going to have to be in degree mode. Do you remember how to change this? Right? We know it's going to be 57. 13 minutes. How many minutes in an hour? 60. So it's going to be 13 divided by 60. Plus, and it's 15 seconds. How many seconds in an hour? 60 times 60, or 3,600. And so you're going to want to do that on your calculator. So that's 57 plus 15 over 3,600. Okay, so a couple of thoughts. First of all, if you were a fraction mode type person, 57 plus 13 over 60 plus 15 over 3,600. You can do that. However, notice the annoyance that mine gave me a fraction. You can get that changed to a decimal. For me, it's the math button. And when I bring up that math menu, number 2 says decimal, right? So if I pick that and then hit enter, it's going to take me to a decimal. If you would have just done 57 plus 13 divided by 60 plus 15 divided by 3,600, that works as well. Maybe a little bit easier. But you should be getting that number for your degrees. Did you get that number for your degrees? And so when we do this, I'm going to be doing the tangent of 57.22083, so on and so forth, degrees. Now, I don't know about you guys, but I have zero interest in retyping that in. Do you know how to go up and copy the previous answer? If I do tangent, and then what am I wanting to do tangent of? That 57 number. If I arrow up and highlight it, and I hit enter, it brings it down and puts it in my problem where I was working. And then I hit enter. The tangent of 57 degrees is this 1.552936056, or approximately 1.553. Now, Ethan, are you going to tell me you can't arrow up? Okay, so here's another option. Skip the middle step. Tangent of 57 plus 13 divided by 60 plus 15 divided by 3,600. Type it all in right there. You can do that. Notice I get the same answer if you aren't able to arrow up. Now, I have to do, yikes, one of the bottom row. So you know how to do the bottom row. Give me your attention. What's different about the bottom row? Do we have a cotangent button? No, we don't have a cotangent button. But cotangent is a reciprocal of tangent. Do not use tan -1, the second function. That's inverse, different. Don't do it. What you're going to have to do, reciprocal, do the tangent of -pi/10 raised to the -1. So by hand, raise it to the -1. And this is going to be in radian mode. I'll demonstrate real quick. So I can do tangent of -pi divided by 10. And then, sorry you can't see, I'm going to raise it like an exponent to -1. That is not the same as using the cosine -1, sine -1, tangent -1. Whoops. Except I'm still in degrees. I forgot to change my mode to radians. So, get out of there. I'm going to redo it. There's your correct answer of -3.078. Okay, guys. Try this on homework. Yes, plan for homework to be due tomorrow. We'll probably just have a day of catching up with homework and everything else. Got it? Okay, thank you for hanging with me. I will see you guys tomorrow.